According to the National Electrical Code, specifically Section 314.16 bone, a conductor that remains entirely within the box does not contribute to the box fill calculation. In your scenario, you have a total of 13 wires entering the box. However, the grounding conductor benefits from an exception outlined in 314.16 bone, exempting it from the count. This leaves 12 wires subject to the box fill calculation. Furthermore, there are 2 switch yokes being installed within the box. Addressing these, as per 314.16b4, a deduction of 2 conductors is required for each device yoke. This means you have to subtract 2 wires for each of the 2 switches from the maximum allowable number of conductors. This calculation yields a maximum allowable count of 12 minus 2 multiplied by 2, which equals 8 conductors. Consequently, with 12 wires needing to be counted and the box having a capacity for only 8, the box fill is indeed exceeded. The inspector's citation of a violation is accurate in this case. To rectify this situation and adhere to the NEC guidelines, consider either upgrading to a larger box with a higher cubic inch capacity or reducing the number of conductors within the existing box. To understand box fill calculations, let's delve into the specifics of NEC section 314.16. This section provides the rules and guidelines for determining the maximum number of conductors and devices permitted in a box. The goal is to ensure safe and reliable electrical connections. The first step is to accurately count all conductors within the box. This includes all current carrying conductors such as hots and neutrals, as well as any switch legs or travelers. However, as we've discussed, certain exceptions apply. Grounding conductors, under specific conditions, are often exempt from the fill calculation. These specific conditions will be outlined later. Beyond conductors, devices mounted within the box also contribute to the box fill. Switches, receptacles, and other similar devices each have a volume allowance that must be accounted for. This allowance is typically based on the device's yoke or mounting strap. Section 314.16 bone of the NEC deals with general wiring. This section says that each conductor originating inside the box or running through it is counted once. This count is based on the conductor sizes listed in Table 314.16b. If a conductor is not spliced or terminated in the box, and simply runs through it uninterrupted, it is counted only once. This section also details the exception already mentioned regarding conductors that do not leave the box. These conductors are not included in the calculation. Section 314.16b2 addresses clamp fill. If the box contains one or more internal cable clamps, a deduction must be made from the available box volume. This deduction is based on the conductor size, with one conductor volume being subtracted for each clamp. The purpose of this rule is to account for the space occupied by the clamps themselves. Section 314.16b3 deals with fixture stud or hickey fill. Each fixture stud or hickey that is present in the box also requires a deduction. The deduction is based on the conductor size. Section 314.16b4 focuses on device or equipment fill. For each device or equipment, such as the switch or receptacle that is mounted in the box, a deduction must be made. The deduction is equal to twice the conductor volume allowance for the largest conductor connected to the device. This is what you experienced with your switch yokes. Section 314.16b5 addresses equipment grounding conductor fill. This section provides rules for calculating the fill allowance for equipment grounding conductors. In certain situations, multiple equipment grounding conductors can be combined into a single equivalent conductor for the purposes of box fill calculation. Now, let's explore the exceptions to these rules. One key exception, as previously noted, involves grounding conductors. The NEC permits certain grounding conductors to be excluded from the box fill calculation under specific conditions. This is typically when the grounding conductors are short and do not extend beyond the box. The exact requirements are detailed in the code. Another important exception applies to conductors that originate and terminate within the box without leaving it. These conductors, often associated with short jumper wires or control circuits, are also excluded from the box fill calculation. This is because they do not contribute to the overall congestion within the box. Finally, certain types of devices or equipment may have specific box fill allowances that differ from the standard rules. These allowances are typically provided in the manufacturer's instructions or in the NEC itself. In your specific situation, you have 314/3 non-metallic cables and 214/2 non-metallic cables entering the box. This equates to 3 times 3, which is 9 conductors from the 14/3 cables, and 2 times 2, which is 4 conductors from the 14/2 cables, totaling 13 conductors. There's also one ground wire. The box has a listed size of 34.4 cubic inches, which should allow for 16 number 14 American wire gauge wires, based on the NEC table. However, you have 2 devices, a 3-way switch and a 4-way switch, to be mounted in the box. Let's break down the calculation step by step. Firstly, count the total number of conductors. As calculated above, there are 13 conductors plus 1 ground, totaling 14. Secondly, consider the grounding conductor. As per 314.16 bone exception, the grounding conductor can be exempted. This leaves 13 conductors to be counted. Thirdly, account for device yokes. 314.16b4 requires a deduction of 2 wires for each device yoke. With 2 devices, that's 2 times 2, equaling a deduction of 4 wires. Fourthly, determine the allowable number of wires. Subtract the device yoke deduction from the initial conductor count. In this case, that's 16 allowable wires minus 4, equaling 12. And finally, compare the actual wire count to the allowable wire count. You have 13 wires to be counted, but the adjusted allowable wire count is 12. This confirms that you are exceeding the box fill capacity. Now, let's address the confusing aspect of 314.16 bone, which states that a conductor, no part of which leaves the box, shall not be counted. This refers to situations where a conductor originates and terminates within the box itself, such as a jumper wire used to connect 2 devices. However, in your scenario, all the conductors from the non-metallic cables enter and exit the box, meaning they must be counted. Remember that the inspector's role is to ensure that electrical installations comply with the NEC to protect people and property from electrical hazards. Box fill calculations are a critical part of this process. Overfilled boxes can lead to overheating, insulation damage, and potential fire hazards. Therefore, it's essential to understand and apply these rules correctly. The NEC is updated regularly, so it's important to stay current with the latest edition. Changes and revisions are made to address new technologies, emerging safety concerns, and interpretations of existing rules. In the 2008 NEC, which is the edition you mentioned, the relevant sections regarding box fill calculations are similar to those in later editions. However, it's always best to consult the specific edition that is enforced in your jurisdiction. Furthermore, it's worth noting that plastic boxes, like the one you're using, have specific fill requirements that may differ from metal boxes. The manufacturer's markings on the box should indicate its cubic inch capacity, which is a crucial piece of information for calculating box fill. When in doubt, consult with a qualified electrician or electrical inspector. They can provide expert guidance and ensure that your electrical installations comply with all applicable codes and standards. Also, using a box fill calculator app or online tool can help streamline the calculation process and minimize the risk of errors. These tools typically incorporate the NEC rules and automatically perform the necessary calculations based on the information you input. Maintaining accurate records of your box fill calculations can also be beneficial. This documentation can be helpful when discussing the installation with an inspector or for future reference. In summary, understanding and applying the NEC box fill rules is crucial for ensuring safe and compliant electrical installations. By carefully counting conductors, accounting for device yokes, and considering any applicable exceptions, you can avoid code violations and create reliable electrical connections. And remember, when in doubt, seek guidance from a qualified professional.